10, and 13 is 4. And yeah, they seem like common sense answers, but that's the reason for those common sense answers. 27. 27 to 30. Oh, I like this problem a lot. PB is 7.1. DE is 13.1. DAC is 33, and DEP is 28.5.
I got 7.45. Wait, what was 28?
I'll just plug in at like
13.1.
I put it to the nearest 33.
You put it as what?
Okay, I was kind of close.
Okay.
13.11 and 7.8.
Okay.
Oh, wait, what was 29?
33.
Okay.
30 was 28.5. Any of those four you'd like to discuss? All right. 32. All right. Do you have enough info? In 32, let me get those diagrams up. Do you have congruent segments from a point to other endpoints? Do you have perpendicular lines? Do you have congruent distances? (32) What information do you have here?
Angles.
You have congruent angles. All right, you got tick marks. So we're dealing with the bisector. We have this is a measure of 5 and this is a measure of x. Do we have enough information to say that x is 5?
Yes.
Why? Well, one at a time. I hear two different things here. Street first, and then Tamia says something different.
If it's an angle bisector, if you make a segment from the side of the angle to the bisector, that segment will be congruent if you made it from the opposite side.
Okay. Tamia, what'd you say?
That was like the same
I
thing.
think you used some different words. What'd you say?
Oh, I was going to say, since the angles are congruent, like the lines from the angle, if you connect it to the angle bisector, then it would be the same.
If you connect it to the angle bisector, what was the end of your sentence?
It would be the same.
It would be the same?
Yeah.
Julia?
I think no, because you don't really know the distance. Well, you don't know how, like if the two lines would meet at right angles to the sides of the so you really only have to do
What piece of information do you have?
that the angle is congruent because it's bisected, and then they share the same side.
And they share a side. Okay. So taking it back to congruent triangles, you have congruent angles and you have one pair of sides, that reflexive side. You don't know this, you don't know that. This is an x and that's a 5. And what's that key piece of information you mentioned? You don't know how it meets. You don't know that they make a right angle. You don't know that the lines are perpendicular. So you can't measure distances until you can guarantee that you're dealing with perpendicular lines. If you do this, then you would have enough. All right, this is a perpendicular, so now I can measure distance. This is a perpendicular, I can measure distance. You don't know that. So you don't have enough information to say that x is going to be 5. You're missing that perpendicular part, so you can't measure distance. What about 33? Do you have enough info in 33? No? What are we missing? Kelly, what are you missing?
You don't know if the segments are congruent.
Which segments?
The ones going into the bisector.
The ones going to the bisector? Have enough info.
34?
34.
No.
A lot of no's. What are we missing?
The perpendicular.
We're missing perpendicular lines. So again, thinking about congruent triangles, we don't know any angle measures, and all we have is two pairs of sides. So we would need at least one more piece of information there to determine that x was going to be 7, or those distances were going to be the same. And at 35, do you have enough info?
Yeah. I put
I hear conflicting information. That's good. What do you know?
It's perpendicular. Yeah.
We have perpendiculars, all right? So again, go back to your congruent triangles. We have one pair of congruent angles. Right here and right here, there are right angles. And they're perpendicular lines, so we can think distance. What else do we have? Do we have any pairs of sides that are congruent?
Yeah, the reflexive.
The reflexive side, all right? Do we have anything else that we know?
That's not enough.
Nothing. We got an angle, pair of angles and a pair of sides. Not enough info.
It's enough to keep it congruent. I mean, but it's not enough to find the value of that.
Not enough to find the value of x, and we're lacking enough. We can't say they're congruent. Even using one of the fancy right triangle postulates of hypotenuse leg, hypotenuse leg is the one where you can use angle side side. We don't have enough info here because we don't know the hypotenuses are congruent. But one of the rare cases where they give you a set of problems in a text and every single one of them is a no or not enough info. What was next? 37?
No, 12.
I didn't give you 37? No, that was supposed to be for today. Okay. So now we go over to 340.
Number 12.
Okay, we're going back to the proof.
Do I have the proof?
We're going to go back to it. The coordinates of the centroid are 9 and 2. X is 9, Y is 2.
I have 9.5.
9.5.
Yeah, I don't know why.
Is the centroid ever outside of the triangle?
No.
No, centroid's one of the ones that's always inside. It's always on the interior. So whatever coordinate you come up with needs to be on the interior. That's a starting point. What should you be figuring out for centroids? What special point should you be figuring out for centroids? It's midpoints, yep. So you need the midpoint of xy and the midpoint of yz and the midpoint of, what did I not say, xz. And then you need to construct a median from a vertex to a midpoint. Or if you didn't sketch it, once you find your midpoints, you're going from a vertex to a midpoint. You're using those 2 points to come up with an equation. Let's see, 345? 40?
Oh, yeah.
Okay. What's the midpoint of xy?
7.2.
7.2? What's the midpoint of yz?
I just did it for one.
Did you have to find the midpoint of like all of them? Because I just find the midpoint of X and Y. Oh, I didn't use midpoints
Yeah.
at all.
Example?
And then when I labeled that, like I got 7.2, I labeled that A, and then I plotted that. And then
Yeah.
Yeah, it's easier, but you also need to remember how to solve a system. Oh, so then you're good.
wasn't it like number 14?
Wait, Miss,
Number 14 had like
Yeah,
Yes, for an orthocenter, most of the time you're going to have to use a system. That was annoying because you got to find perpendicular slopes and they come up with the new equations. Now, the thing that Khadijah mentioned, that 2/3 thing, is always going to apply in a centroid. And that makes it nice on a horizontal line because you can just count the spaces and then figure out where 2/3 of the way or where 1/3 of the way is down that line. Absolutely works, yeah?
No.
I got this.
No, this is a simple question.
I looked up on Google and apparently if you got all the x's and divided by 3 and add all the y's divided by 3, you get the.
That is apparently true.
Okay.
So can we use that?
How do you find
I'm still debating that.
the 2/3 thing again? Because isn't okay? I got 5, and isn't so I got okay. So for one of the points I got 7.2 as the midpoint for the other side. And then
Yeah, that's for XY, yep.
And then I did 13 minus 7. I
Mhm.
got 5. And then I
Six.
found. That's where I went wrong.
That's where you went wrong, was
Because I
addition.
got 7.5
Yep.
instead of.
Okay. Anything else on number 12?
Is 14? Is that a 9?
14 is a nice answer.
Oh, I think, okay.
What's that, Julia? Okay. 5, -1 for number 14.
What? 14?
I got one, how about you?
I got.
-8, -9.
I got
Five,
one.
one.
And it works when I put it behind.
I got 5-1.
So that's.
5, -1?
Negative one, one negative.
Yeah, that's it.
I got 1, 2.
3, 4.
5, 6.
7, 8, 11, 12.
I don't remember offhand what the equations were. You want to do 14?
Yeah, because I remember it's and they were.
I don't have. What's the 3, -2?
Yeah, 5, 6.
5, 6?
Yeah, and then 9, -2.
9?
One of the problems.
I said that it was supposed to be a good answer, like a nice.
Equation between these 2 points?
6 + 2, 5 minus.
Slope is -2?
I didn't get that.
Well, let's see. 6 minus -2, 5 minus 3 is 8 over 2, which is 4.
JK, I think that's what I got.
I mean, this is
So if your
great.
slope's wrong, then that's gonna mess up.
Oh, wait.
Add something to the
Okay, this is the slope of the segment connecting these 2 points.
JK.
You get the opposite reciprocal, and you want to go through which point?
L, 9, -2.
Through 9, -2. So you find the slope of this line, make your opposite reciprocal, and you're going to use this slope and this point. That's going to be your equation. So your equation is y minus a -2 equals -1/4 x minus 9. So we get a y value, let's see, our equation, -1/4 x. This is 8/4 plus a quarter. And now I need a new equation, so I'm going to pick 2 new coordinates and a new point. So let's choose, oh, this is a nice one, because this is a what kind of line? They have a y value in common. So this is a horizontal line if the y value doesn't change.
I did this all wrong.
That would be like 3. I did 5 minus 3 over 6
Why does that not work out?
minus -2. So I got
You should get negative
1/4,
plus
so I got
9.
-4.
What happens when we solve this?
Oh, never mind.
Oh wait, but okay, this is only, I'm sorry, this is only the equation of the line for this segment. This is, okay, let's label it. This is an actual altitude.
Right.
This is a triangle segment. So there are 2 different things here. So that makes it a little harder here. I need to know where 5, 6, the line that goes from 5, 6 to y equals -2. The slope is not undefined. It's defined. It's undefined if it's vertical. Oh, you're talking about the perpendicular line. I'm sorry. Then you're correct. Absolutely. It is going to be a vertical line if we need to be perpendicular to this segment. So it's going to be an x equals.
And then since the y value doesn't change, it's going to be 5.
So again, we want perpendicular to this line. So here's what we need to do. Perpendicular said is the undefined slope. So it's going to be an x equals something equation. Then it's got to be a vertical line through this point. So it's going to go through, as you said, 5. The other altitude. is x equals 5. Now we have two altitudes.
Yeah,
So you don't count your -2 for the altitude?
No, I didn't label my points well enough. This was a segment just like this was the slope of the segment here. This is a triangle segment slope. And this is a triangle segment slope. Oh, this is the segment, here's your slope. We needed to come up with the altitude equation we did here. I didn't come up with the altitude equation over here. Your altitude equation is 5. So now we can use our 5 and find the intersection of y equals blah, 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 and x equals 5. And that's a nice plug-in. Which is a good strategy to look at your points first and see if you have any horizontal or vertical lines you're dealing with before you go through and come up with, I mean, we could have chosen 5, 6, and 9, -2, and had a nice slope-intercept equation. But coming up with x equals 5 is a lot easier. Your x value was 4 3/4, your y value was 6, and your z value was 1.
wait, hold on. Wait, can you say that again?
4 3/4, 6, and 1.
I got 4 3/4, 7 and 4 and 3/4. I got 8 and 3. 8 and 1/4. 8 and 1/4. 8.2.
We didn't get 44.
So it's the y and the z that didn't go well?
No, I got the x. The y and z were good.
Okay.
I got 7 for Y.
You got 7 for y?
Wait, what was z again? 1?
1.
Oh, wait, I got
Why 6?
What was X?
I got all but Y.
What was X?
1 3/4, 4.75.
Yeah.
Oh, okay.
This is, you have to use your 2/3 relationship. Your 2/3, 1/3 is 2 of QL, or half of HQ is QL, or HQ is 2/3 HL, or QL is 1/3 HL. Any of those will work for HL, and similarly they'll work for KP and JM as well. So let's look at the K's first. KP, you have KQ, and you know QP. Jordan, which one of those do you want to use there? Do you want to use the half relationship? Do you want to use the thirds?
Thirds.
You want to use the thirds? So let's go with KQ. KQ is 2/3 KP. Do you know what the measure KQ is?
KQ, 7.
7. Do you know what KP is?
KP
Yep.
is 7 plus 2 equals 6.
Yep. That whole thing. So let's simplify here. You get 7 equals 2/3 1 plus 2x. So you'll get 2/3 plus 4/3 x. 2/34 is enough. Hi. Can I send her in like 5 minutes? Okay. You're welcome. You gotta see Miss Baginski in a couple minutes.
Me?
Yeah. Here's the whole for. We get 2/3 plus 4/3 x. 7 is the same as 21/3, so subtract 2 from 21, we get 19/3 is 4/3 x. And if we multiply by 3/4, our denominators reduce each other, and we get 19/4 equals x, which is the same as 4 3/4. Okay? You can do the same thing. You can use any of those other relationships as long as you know you're dealing with the centroid, or as long as you know you're dealing with medians, or as long as you know that you have segments that connect to a midpoint. All those things go together.
Yeah.
24, angle 1 is 35 and angle 2 is 55. $25. Your x value is 6. Is EC a median of AED, Mr. Pascal?
No.
It is not, because the measure of ECA is 92. So ECA is not a right angle, so you do not have an altitude. $34, you are told you have an altitude. Your x value is 32.
Yep.
And 35.
That's